Hey students, this is lesson 3.6. In this lesson, we will learn how to solve and graph inequalities containing the word and solve and graph inequalities containing the word or. We'll also learn the significance of the word and or. Go ahead and do this review and I'll check back with you. All right, writing a compound inequality. What compound inequality represents each given phrase? All real numbers that are greater than 1 and less than 5. So we're looking at two things separately. All real numbers that are greater than 1 and all real numbers that are less than 5. So we have all real numbers greater than 1 looks like this. So x greater than 1, and then we're going to use the word and. And the red underlined part, all real numbers that are less than 5, looks like this. Okay, and if we're using the word and, that means there are numbers in between 1 and 5. So we can actually write that with in a different way. We can put 1 as the lower part, and then all the real numbers will be greater than that, and all the real numbers will be less than 5. So we can combine the and into one inequality like that. And then if I make a number line for that, so on our number line, we're talking about numbers like 2, 3, 4, all those in there, and our endpoint is 1, and it's got to be has to be greater than 1, so we're not going to include 1, and we're not going to include 5, so we're going to put an open circle. And then I'll just draw a line to represent the numbers in between, like that. All right? And the second one says all real numbers that are less than 10 or greater than 15. Now that's a little bit different. So we have all real numbers that are less than 10, and we have all real numbers that are greater than 15. And we have an or between them. So all real numbers that are less than 10, that looks like that, or all real numbers that are greater than 15. Now with this, we actually have two different sets, not like a combination. So I can't write this as one inequality like I did the one up above. And you can never do that when you have an or statement. But, so I'm done here. I'm just going to graph these. And less than or equal to 10, I'm going to need a little bigger graph here. So for this one, my endpoint is 10. And I want numbers that are less than 10. I need a bigger still. Okay, so my endpoint is 10. So, and since it's less than 10, I'm going to put an open circle. Now I'm going to be going to the left of that. So I need to draw my line this way. And then I'm going to put an open circle on 15. And greater than 15 will be in this direction. All right? So any number this way and any number this way. And that's the reason for the or, because it can either be in this set or it can be in this set. All right, I'm going to let you try that. All right, solving a compound inequality. So I have a compound inequality here, and this is an and we can tell because it's all in one. So we really have two separate ones here. We have negative 2 is less than x plus 2. And x plus 2 is less than or equal to 5. And to solve this one, I'm just going to subtract 2 from both sides. And I get negative 4 is less than x. And subtract 2 from both sides here, and I get x is less than or equal to 3. Now notice I did the same thing on both of those. So what I really could do is just subtract 2 from the 3 parts up here, and I'll get the same results, but in one simpler compound inequality. So negative 2 minus 2 is negative 4, less than x plus 2 minus 2 is just x, and 5 minus 2 is 3. And so there's my compound inequality. Now I want to graph that. So I need all numbers that are bigger than negative 4, but not including negative 4, so put an open circle there. And together with less than or equal to 3, so I'm going to put a closed circle on 3. And then I'm just going to draw a line in between them to represent all the numbers that will work. All right, you try that. All right, we're going to write and solve a compound inequality here for this problem. It says, to win a recycling contest, you must collect between 83 and 87 pop tabs each week, inclusive. That means it's including 83 and 87. Suppose you collected 82, 86, and 84 pop tabs during the first 3 weeks of the competition. What are the possible numbers of pop tabs you can collect during the fourth and final week? So let's define a variable n as the number we collect on the fourth week. Okay, so if that's the number we collected on the fourth week, then the expression n plus 82 plus 86 plus 84 represents the total we collected. And then to find out the number we collected each week, it's really an average of how many we collected each week. We need to divide by the number of weeks. Now we want that to be between 83 and 87, including 83 and 87. So to get that to include 83, we're going to do less than or equal to sign. And to be including 87 but be less than 87, we're going to do less than or equal to there also. Now to solve this, first thing I want to do is get rid of this divide by 4. So I'm going to multiply everything by 4. So we'll do 4 times there. We're going to multiply this whole thing times 4. Maybe move this over a little if I can. And we're going to do 87 times 4. Now when I do that, 4 times 83 is 333. And that needs to be less than or equal to that should be 332 is less than or equal to, and notice I simplified this. I just combined the 82, 86, and 84 and made it 252. All right, now I just need to subtract 252 from each of those. And when I do that, I get 200 and actually get 80 is less than or equal to, and is less than or equal to 96. I made another error there, didn't I? No, that's right. 80 is less than or equal to n, is less than or equal to 96. So what we're going to say here is that in order to win the recycling contest, we must collect between 80 and 96 on the last week. All right, I'll let you try that. All right. Solving a compound inequality with 4. To solve this, we just really need to solve 2 different things. So, so I'm just going to solve each of these individually here. I'll just add 1 to both sides, and I get 2n is less than negative 2. Divided by 2, I get n is less than negative 1. 4. And then solve this over here, subtract 2 from both sides, and I get negative 3n is less than negative 6. Divide by negative 3. And I get n is, got to switch the sign there, greater than 2. All right, and then to graph those, I would just get a number line. And on my number line, I would circle negative 1. And it needs to be less than -1, so I'm going to go to the left of that one. And greater than 2, I need to go to the right of that one. All right, you try that. All right, and the last thing we're going to learn is how to use interval notation. Interval notation is just making kind of like an ordered pair that represents the interval in the numbers you're dealing with. So you're going to use brackets when you have less than or equal to or greater than or equal to. And so a bracket means it includes that endpoint. We're going to use parentheses when we have just less than or greater than, or when we don't want to include that number in the set. And to show that we're going on forever to the end, and it never quits, we're going to use the infinity symbol. And just so you know, infinity or negative infinity is never included. So we always use parentheses with the infinity. All right, and here's how it works. I'm just going to give you a couple examples. So let's say we want to do this set where -4 is less than x, and x is less than or equal to 5. And I want to use this notation. To do that, I'm going to, since I don't want to include -4, I'm going to start by using a parenthesis, -4, and then a comma. Now, when you use interval notation, you just assume that you're going to keep going. So I'm going from -4, and you always put the lowest number first. Then I'm going to go all the way up to 5, and I want to include 5, and the way I show that is I use a bracket. So that's how you would do something like that. If I just want to do something like this, x is less than or equal to 5. The lowest number in this set, there is no lower bound. It goes all the way to negative infinity here. So, and negative infinity is not included. So I would do that like that, negative infinity symbol, comma. Now I want to go all the way up to 5, and I want to include 5. So I'm going to use a bracket to include that. All right, you go ahead and try that. All right, that's it for the lesson. Go ahead and do the lesson check, and I'll see you next time in class.